In this video, we're just going to take a look at three of the ratios that exist within a right angle triangle between the sides in relation to a given angle within the triangle. So the first thing we've got to look at is, in a right angle triangle, there's a way that we can name all of the sides in relation to a specific angle. So the first side we're going to look at is the one out here to the left called the hypotenuse. The hypotenuse will always be the longest side in any right angle triangle, and it'll always be the side that is directly across from the right angle. So we can see on our diagram here, the longest side and the one directly across the right angle is marked H for hypotenuse. Now what we're going to look at next is the sides in relation to this angle marked in the bottom left, theta. So this symbol down here is the Greek letter theta. The first side we're going to look at is the side over to the right here, which is the side that is on the opposite side of the triangle from our angle that we're looking at. And because it is on the opposite side of the triangle from the angle we're looking at, we're going to call it the opposite. And the last one that we're going to look at is the side down here marked A, which is adjacent to or beside the angle that we're looking at, this theta. So that is going to be our adjacent angle, our adjacent side, sorry. So now that we've got the sides named, what we're going to do is we're going to take a look at three specific ratios that exist between these sides in relation to that angle theta. The first we're going to look at is the sine of theta. So the sine of theta is what you get when you put the length of the opposite side over the length of the hypotenuse. So it's O over H, like that. And the next we're going to look at is the cosine, which we write as cos of theta. And that's what you get when you put the length of the adjacent side, the A side, over the length of hypotenuse, the H side. So that's A over H. And the last one we're going to look at is the tangent of theta, which we will abbreviate as tan. So tan theta is what you get when you put the length of the opposite side over the length of the adjacent side. Opposite over adjacent. As a side note for this, the tan of theta is equal to the sine of theta all over the cos of theta. Now that may not come up too much, but it's just worthwhile noting in case it does. So now that we've got them together, we've got to see if there's a way we can try to remember what order this all goes in. Now, but as long as they are written in the order sine, cos, tan, there's a mnemonic that can be used to try and remember this, which is oh hell, another hour of algebra. So oh hell, OH, opposite hypotenuse, another hour, AH, adjacent hypotenuse, and of algebra, which is OA, opposite and adjacent. So that might be a way that is useful for you to try and remember this. What we'll do is we'll take a look at an example now with some real numbers so we can see how these are put to use. So in this triangle here, we've got a right angle triangle with the sides marked 5, 4, and 3, and two angles marked A and B. And we're going to try and get the sine, cos, and tan of each of these. So we'll start with the A ones there. So for A, we're going to make this a bit easier on ourselves, and we're going to get the length of our hypotenuse, the length of the opposite, and the length of the adjacent side to A. So the hypotenuse is the line that is directly across the right angle, so that's going to be 5. The opposite is the line that is on the opposite side of the shape from A, which is going to be 4. And the adjacent is going to be the side that is adjacent to or beside A, which is just going to be the 3 down here. And if we remember from above, our sine, cos, and tan, our ratios for them are OH, AH, OA. So Sine A is already marked in for us in this. We can see it here. It's opposite over adjacent, 4 over 5. Nice and straightforward. Our cos A, if we look to the right, is going to be adjacent over hypotenuse. Adjacent is 3, hypotenuse is 5. So our cos of A is going to be 3/5. And our tan is going to be opposite over adjacent. Opposite is 4, adjacent is 3, so it's going to be 4/3 for that, for our tan of A. Now we've got to get our sine, cos, and tan of B, which means we've got to go about naming out the sides again, so we know what numbers to put in for this. Okay, well the hypotenuse doesn't change. No matter which angle we're talking about here, the hypotenuse is still the hypotenuse. It's still the side directly across the right angle. It's still the longest side in the triangle, so it's going to be 5. But our opposite will change now that we're talking about B, because the side that is opposite to B, that is on the other side of the triangle from B, is now the side marked 3 in our diagram. And the side that is adjacent to B, or beside B, is the side marked 4. So our adjacent is 4 this time. So now we go about getting our sine of B. It's opposite over hypotenuse, so it's going to be 3/5. And then for our cos of B, it's going to be adjacent over hypotenuse, which is going to be 4/5. And then our last one for our tan of B, it's going to be opposite over adjacent, so 3 over 4. So it's going to be 3/4. And that is how that is worked out.